Welcome to Blue Pen Land. This is a good problem to start with because this is actually a fairly accessible IB test question. Let's just take a look at this, right? The first one's actually just asking you to SUVAT, okay? So S-U-V-A-N-T, right? It reaches a speed of 27 meters per second, right, from rest. Notice that, right? So this is 0. This is 27, and then the time is 11 seconds, right? And so what you're going to do is, I guess, use no A to find S, right? Okay, and then so show your work, show the formula you're going to use, then show the answer you arrived at. I think that's probably what the 2 marks are for, right? We're coming up with 2 things, right? And then for B, you're going to actually have to solve for the acceleration, right? So solve this thing, right? So this is 27, this is 0, this is 11 seconds, right? Solve for the acceleration. It's not too hard, right? So that's our first step. And then, of course, this airplane is going to be, here's my airplane, right? There it is. It's 492 kilograms, right? And then there's going to be some force this way, and that's what you're trying to find out, right? And then the force backwards, there's a retarding force of 160 newtons, right? So then you're going to set up a force minus force equals m times a, right? And then solve for whatever that force is, right? This force is positive, this guy's negative. So force minus force equals m times a. And then you can solve for what that force is, right? And you have to use this acceleration that you get here. Right, so there's 3 marks, right? I don't know what the marks are for. I'm supposed to find the acceleration, right? Set up this expression, then arrive at the answer, right? Okay, so that's the first page. The first page is a good confidence builder, right? Second page, this isn't too bad either. Okay, the cable is pulled by an electric motor, has an efficiency of 23%. So our efficiency is 0.23. Remember, that's what that means, right? And determine the average power input to the motor. Well, ultimately, we're also going to use what? That efficiency equals power output over power input. And this is what we're trying to find. The power input is this guy, right? This is our 0.23, so we're going to plug that in, right? And then the question is, what is our power output? Well, the power output is going to be the power that we had to exert on this glider, right, to make the glider accelerate, right? So there's lots of ways to find that power output. The way I chose to do it was I said that the power output, the average power output, because notice it's saying the average, right? Okay. The average power output is going to be force times the average velocity, right? And the average velocity will be the average of 0 plus 27, right? That's our average velocity. So that's what, 13.5 meters per second. And then the force will be that force that you figured out, the total force, the net force in part B, okay? So whatever that force is, and show that work. So even if you got this wrong, you can still get this question right by using the force that you had. So this is the easiest thing, I think, right? You also could do the power output, the average power output. That little line over it just means average, right? Is just work divided by time. The work is literally our force times our distance over time. And I believe you calculated the distance in part A. And you calculated the force in part B. And the time is 11 seconds, right? Okay, so you could do it that way. Another way to find the average power output, these all should be pretty much the same, right, is to use kinetic energy, right, over time, okay? So happy hunting, whichever way makes sense to you. I did this because I'm lazy. Okay, and then this guy here, notice that the key concept here is that this airplane's moving at a constant speed, right? The unpowered glider moves off horizontally. The wings of the glider produce a lift force. The diagram shows the lift force acting on it. The unpowered glider, how could it possibly move horizontally at a constant speed? But let's not argue with them. Okay, so notice that this lift force has a vertical component and a horizontal component. Okay, you're going to have two forces. You're going to have the drag force, and the drag force acts opposite the direction of motion, right? So there'd be a force to the right. Draw it to the right length. You're also going to have the force of gravity, right? The weight, or the force of gravity. W-E-I-G-H-T. Is that how you spell weight? I don't even know. Okay, so it looks right to me, but it's late. So of course the force of gravity would be straight down. Now I'll give you a clue. If it's moving at a constant speed, these three forces are going to add up to 0. That means that the force backwards should look like it's as long as that component. The force downward should look like it's the opposite of that one, right? And then on free body diagrams, I guess the rule is that you got to make the arrows, the tail of the arrow, touch that dot, okay? So make them emanate from that dot. Draw an arrow to the right, the proper length, an arrow down to the proper length, so that these will all add up to 0. I don't think there's anything else I can say about this problem.